Okay, so I have all this in place, and I even made this instack.cpp implementation file part of my project, but the compiler has no clue what this is, right? It doesn't care that the name of it is the same as my header file. I really have to include the header file, which I already did in my main program. So likewise, I will do it here, right? So this time everything looks more or less okay. I don't know why this guy is unhappy. Cannot open. What's wrong with this? No, nothing wrong. So I don't care. All right. So here we go. So and I think we explained this before, that it's possible to organize the storage, as an array of integers. Now we should have a discussion on pointers and arrays and other indirect features that are related in C and C++. But for now, I will just give you an example of how it looks like. Integer m storage, right? Storage. And I can also say initial storage size, right? And I need to define my initial storage size, and I can define it as small as static const int storage size equals like 10 elements. So this declaration of storage creates an array of this size of integers, like an array of integers of this size. So I'm going to get 10 integers physically instantiated inside my object. So inside this object that is going to be allocated in memory, there will be 10 integers present there. Then, of course, I said that it would be nice to have a stack pointer, So what I'm going to do is right away I'm going to say that these are my constructors, right? So in my constructors, I am going to say the name of the constructor is going to be the same as name of the class. That's the rule. That's how compiler recognizes that this is a constructor. And over here, I will definitely say that my stack pointer should be pointing to the initial element, which is element number 0. In that case, when I say push, right, I can say
inside the header?
Oh, you caught me. Yes, you can do this. Yeah, let's move it. Good one. You caught me. Yes, you can write it in line. I'm trying not to, but it ran away from me. Control C. Okay, so I will move it to the definition, to the implementation file, and remove it quickly as if I didn't do it. Okay, so the reason for doing this, right? The reason to actually do this in separate implementation and not write everything in your declaration in line. That was called inline, writing just like people do it in Java. Like in Java, everything is written in line. So the reason not to do it, because sometimes you can create interdependencies. Like you have to include one header file, another header file, and something else. And sometimes this will get in the way that compiler will become unhappy, and there will be some undefined pieces. But if you keep your header files clean and include just the header files and keep all implementations separately, you will never run into any compile problems due to some dependencies of your classes. It's like sometimes you can write a definition here directly in line, but what's going to happen is that the compiler will sometimes say, "Oh, I don't recognize this object or that object," and at some point we can demonstrate that. So again, I'm just trying to do this and keep the implementation file separate from the header file. An additional benefit is that this looks very neat and clean in terms of the interface. You basically say, this is what my object, what my class can do, right? So these are the operations, and these are the constructors, and then anyone can examine what the data members are and what the internal pieces are, because by default everything inside InStack is private. So this is public. So now my main function should be happier. So let's see what happens here. If I first of all, can I build this? Right. So it says pop must return a value. What I just did here was that I tried to create a definition of a function, but it promises to return an integer. So I need to return something. Return 0, right? So that should work. All right, so building it is not a problem. So if I try to run it, it's not going to do anything, because it just returns 0 from pop, so it should print 2 zeros and nothing interesting. I'm not going to waste my time running it. So once you have an array like this, you can access your array through this. Like push can say storage, and my stack pointer, recall that my stack pointer is initialized to 0 by the constructor. So as soon as I instantiate my InStack, the stack pointer is set to 0. So when I go to my implementation here, it's safe for me to use MSP and store this value. Now I really dislike single character, let me say like element or something, right? So I will keep this consistent in my header declaration as well, right? So push element, push brand new element into this container. So I will use it as element. Okay, and then when I return, so it's going to be doing the same thing, return stack pointer. However, we said that the promise was that in order to be able to provide new location for each storage, then you have to say, let's just increment the stack pointer, right? Let's just increment the stack pointer so that the next time we come back to push something, we already know that we previously incremented the stack pointer, so our stack is ready to accept the new value, right? And similarly, inside pop, we need to do the opposite and basically say, oh no, push never happened. So let's come back to where we were and then return them the element from the storage. And the stack pointer points to, it's an index. It's not really a C++ pointer. It's just a normal integer, right? A normal integer that just stores values like 0, 1, 2, 3. Okay, so now if I run this, right, recall I tried to push some values. So if I run it, build and run it, I can run it here in debug mode, exits right away. But here they are, right? So the pop really worked, the push really worked, and it seems to be working properly. Any questions about this? So basically we have implementation file, we have, right, and we also have a header file that declares functions. We can expand this list of operations and add more stuff to it. We also created storage, which is an array of integers of this size. And it gets so this is huge limitation in our implementation, because what happens here that you cannot push more than 10 elements on the stack, right? Because otherwise, if I keep pushing, something bad will happen, right? So if I keep pushing here, I don't know how many I'm trying to push, but at some point, the 10th element, and I will exceed, and then I will no longer, in this push, I will be using this expression, go to location such and such inside the array and try to store the element there. But as soon as index goes out of bounds, the CPU will catch catch me. And if I try to compile it, right? So if I try to compile it and run it, hopefully we'll see debug, start debugging, right? So it says unhandled exception, access violation, writing to location, a break, and it just happens to be on this line right here. So yes, of course, we're attempting to store it, but no longer are capable of doing this, and so it's really unfortunate. Okay, so there is no protection against this right now in what we built so far. So debug, stop debugging. So obviously we need to kind of stop doing the silly stuff, right? So there's just no need to do any of that. All right, so that should give you the idea what I'm expecting you to do. To work with these two files, right? To work with the main program and then follow the instructions. So let's continue reading the instructions. Make sure these routines maintain the integrity of the object under error condition and such and such. Okay, potential, a demo could be here that if push should be, should behave defensively, maybe it should say something like this. If this stack pointer is greater than the storage size, right? So if really kind of outgrown, this size, actually the last element is 9 in case if this is initialized to 0. So it's like greater or equal to initial storage size. It means that the capacity is already exhausted, right? So we can use this other standard string, C error string, to print a message. Maybe something like this: stack is full, right? And just give them a message, an error message. This looks like a diagnostic error message, but anyhow, this may be helpful for a programmer to see that it's happening. Now, also look at this. Regardless that I have included the IO stream in my main CPP, remember, each CPP file is compiled absolutely independently from anything else, and in this case, I must, in order to be able to use any standard library facilities such as cout or cerror devices, I must include IO stream here as well, because it's just another implementation file.